Cameron here. In the last video, we looked at the throttling characteristics of the Microsoft Surface Book when using the Intel GPU rather than the discrete NVIDIA GPU. And we saw that it did throttle. You're using a CPU and a GPU in a super tight space. But two big questions remain. The first one is, how much can you alleviate the throttling based on undervolting and adjusting the thermal characteristics of the processor? The second question is, will the processor throttle at all if you're using that NVIDIA GPU? Well, let's figure that out. Once again in this video, we're going to go into a lot of depth and spend quite a bit of time looking at what the processor is doing and look at some charts and graphs and see how it reacts to different situations and different settings. If you're not interested in seeing all the details about the in and outs about how that works, go ahead and click here and we will take you to the end of the video where I'll give you a succinct wrap up, hopefully, and you'll be able to get the details without spending 20-30 minutes, however long this video ends up taking. So anyways, let's get started. Okay, let's go ahead and get started. In this first test, we're going to be using stock settings. I have not touched any of the settings on the processor, any of the thermal capacities, things like that. And what we're going to do is run a kind of just an impromptu benchmark using Metal Gear Solid 5. And what I'm going to do is I'm going to run the stopwatch here once we get going and jump into the game, and we'll see how long it takes to start throttling. Now, once we've done that, we'll kind of establish our baseline. We'll let things cool off, get back to a package temperature that's idle, just sitting here speeds, and we'll run it again after both undervolting and adjusting some TDP settings, and then we'll run a third time using the NVIDIA GPU. So let's go ahead and get started on the initial baseline test. So here we go. So you can see the heat rising there. You can see the clocks are stable. We're running this at 1600 by 900 resolution and kind of medium-high settings as it stands in this game. Averaging about 15 frames a second here. Actually, it feels a little smoother than 15 frames a second, but it is what it is. Now, I'm going to let you guys in on a little secret. As you know, this device power limit throttles. And the power limit throttle for this device, or the configurable TDP down, is only 7 watts. That's according to specification. And what I've seen is the package TDP is lets you configure at 15, but then it starts to kind of throttle itself down after it reaches kind of the long period, and it will go into a state that's called power limit 1, and you'll know it's in PL1 because this will turn yellow, and it will do that not because of heat. It will do it just because it thinks that you should not use that much power. So we're going to see that happen in just a minute here, I'm fairly certain. But it's hanging in there so far. You can see the core frequencies throttling slightly. But nothing major here. It's actually hanging in there quite well. This is very different than the graphs we saw on the Surface Pro 3, where it's just, you know, pretty consistent. It's not bouncing around. It's just doing what it's supposed to do until it reaches its limit. And the bad thing is the fact that that TDP limit that's going to kick in here in a minute, it seems to me that it is, well, I'm almost 100% certain that it is hard-coded into the BIOS of this machine. In fact, as I played around with some of the TDP settings, it does not seem to make a difference at all what I actually try to set it to, unfortunately. It doesn't want to listen. So you're kind of limited to a restricted bandwidth, but as you can see, stock settings, it's running pretty well. And you know, these graphics are set to high. I could actually pop them down to low, and this game would actually be completely playable. Okay, there we go. Throttling right at 8 minutes. And there you have it. Bumps down to 1.3. And let's just take a minute here and notice a few things. First thing I'm noticing is, check out the frame rate. It didn't do anything. The throttling really is not affected too much, in games at least, by that core dropping from, you know, 2.3, 2.4 down to the 1.3. It just is not affecting the gameplay. So that's a good sign. You can see where the clocks have dropped though, and that it is throttling. What I've noticed is it'll allow 15 watts, but then when it's throttling, it seems to drop down to about 10.5 watts. I'm not quite sure exactly why that is, but anyways, we just needed this benchmark. This is completely stock, and it took 8 minutes to throttle. So we're going to close out, and we're actually going to do some undervolting. So hang on. Okay, so now what we're going to do is undervolt this thing using the Intel XTU utility. So I'm going to go into the core, and what I'm going to do, there's lots of options in here, but the main ones we need to worry about are the core voltage offset. Now the voltage offset is basically no matter what the voltage is at, because these things vary in their voltage, you can say use whatever you were going to use for the voltage and go down this much in steps. So based on some experience I've had playing around with this, I'm going to have it go down to negative 50 millivolts. And the other thing I'm going to do is turn up the Turbo Boost Power Max. Now, I'm unclear whether this is actually doing anything. And the reason I say that is because I'm going to up it to 25 just for fun. I see no evidence that the package is ever going above 15 watts actually in further testing that I've done on this, and it has some configurable TDP for long power limit that we see kick in that seems to be tied into the BIOS, and it doesn't matter what we put in here. It doesn't seem to really respond to these at all, but I'm going to set them up a little bit higher anyways just to see if it's going to do anything for us. So We've got the core at a negative 50 millivolt. We've got the processor cache at a negative 50 millivolt. And we're going to go into the graphics, and I'm going to also, on the processor voltage, take it down 50 millivolts. So let's go ahead and apply those changes and switch back into monitoring mode. So we're now back at our baseline, and I'm going to start the test. This is optimized Intel graphics in Metal Gear Solid 5, time to throttle. And here we go. So one thing you'll notice is now that we've undervolted the processor, it has a little more overhead, and you can actually see the core frequency is hanging out at 2.9. That's full turbo right now. So that's good and that's bad. It's good because it means that we've created more thermal headroom for ourselves, but it's also bad in that it also is using a higher voltage for that CPU, which may end up heating us up and therefore throttling quicker. But it remains to be seen what the true effects of that are going to be. So while this game might not be benefiting much or even be affected at all from that core frequency, there may be other games that maybe helps out a little bit. But all in all, it's pretty cool to see this machine at 60, in the 60s, full graphics, full core, and running pretty well. Okay, throttling at 645. The interesting thing so far is while it is throttling, it hasn't throttled it down to the full 1.3 core yet. It might get there, but it's going down much more slowly. What it's really trying to do is reduce this package TDP. So it's actually an interesting result. By optimizing the CPU, it ran at a higher frequency, which in turn used more TDP and caused it to throttle a little bit earlier. However, it's not throttling to the same extent yet. It's only at 2 gigahertz on the core frequency rather than the 1.3, 1.4 we saw earlier. But still note, it's not affecting our frame rate. So that is very interesting. The optimized CPU throttles, but the core frequencies stay much higher. That is a stellar result right there. Question is, how long is it going to maintain that 2 gigahertz? Will it be able to keep it, or is it going to drop down to 1.5, 1.4 eventually? Looks like it is going to eventually hit the mark. Okay, there it goes. So, it took a lot longer to throttle further, but it eventually still got there. Now, you may be able to undervolt a little bit further than I was able to without causing instability, and you might be able to get your package TDP down to 10 watts just by undervolting. Probably not likely, but you might be able to do it. The other thing you can do is you can actually disable turbo. That could be an option that would keep you at, well, if you use a program called Throttle Stop, you can actually set the multiplier that you want to be at anyways. You could, just set your CPU at a default 2 gigahertz and keep the package TDP down and never run into throttling at all, which I think it might be a good option for some. But as we can see, it's not attacking when it throttles. It's not attacking the graphics frequency, which is really helping us out. In fact, I see this bumping up to 16 frames a second, even though it's in the throttled state. So, interesting result there. Let's go ahead and move on to the NVIDIA GPU now, though. Okay, so now we are testing on the NVIDIA GPU, and we're going to see if this processor ends up throttling at all when using the GPU. So let's go ahead and get started in 1, 2, 3. So you can see we are running absolute full core frequency. That's the max turbo on this CPU for multiple cores. And you can see that the package TDP is only 8 watts when it's running at that full frequency. What that tells me is this machine is likely not going to throttle at all. It's just not using enough energy for it to start running into power limit throttling. Frame rate is up, which is great. We're on the NVIDIA GPU anyway, so that's kind of what you would expect. We're on high settings at 1600 by 900, so that's a pretty good frame rate. Totally playable. So the core frequency is high, package TDP is low. Now I've tested this in games, and we're just never going to reach a point where this thing is going to throttle. But I'll let it run for the full 8 minutes, and we'll just kind of put it on fast forward. So this is where the device throttled on the last test, but I can tell you it's just not going to throttle from this point on. So let's see what it is going to take to throttle. While this is running, I'm going to go ahead and load up some Prime 95 and let that run in the background as well. You can see our CPU utilization is up to 100% there. And here's the key indicator. The package TDP is now up at 14 watts. This is the point where it's actually going to start to throttle. But it's still going to take a little bit. As you can see, our temperatures are ramping up. Nothing crazy, still around 72 degrees. Once again, all this throttling is not because of heat. It's all because of configured TDP. Okay, so here we are, 11 minutes in. No throttling yet. This is running Prime 95 in the background. The package temperature is up to about 82 degrees Celsius. That's the highest I've ever seen this thing get. Okay, we finally ran into some power limit throttling. That's with CPU-Z running, Prime 95 running, Metal Gear Solid 5 running for 15 minutes straight. And you can see that the throttling is only backing the core frequency down ever so slightly from 2.9 to 2.8 at this point. It may continue. It may not. If it can get the TDP down without reducing core frequencies too much, you basically don't have anything to worry about. Once again, this is totally kind of an outrageous test. You're never going to run into anything that's going to be pegging the CPU as hard as Prime 95 while gaming especially. And that's what it took, 15 minutes of that to actually get it to throttle. And now that it's throttling, it's only throttling it by 100 megahertz. So, we think I can I can't I can't definitively say it does not throttle when using the NVIDIA GPU, but it's pretty safe to say that there's not any effective throttling going on under normal usage when you're using that NVIDIA GPU. I think that's safe to say. So, let's go to the recap. Okay, so what did we learn? We ran 3 tests. The first test was the stock Surface Book using the Intel graphics, and we found that in Metal Gear Solid it took a full 8 minutes before throttling took effect. The other thing we saw is, like the other one, it didn't really affect the performance of the game we were using. Intel has optimized this throttling. It does not normally seem to affect the GPU clock speeds. It keeps the GPU high and throttles the CPU a little bit, and it doesn't really seem to, at least in this Metal Gear Solid test, it didn't affect the frame rate at all. So then we optimized. We undervolted the processor and the GPU by 50 millivolts, and we saw some surprising results. The first thing we saw was that it allowed the CPU to stay turboed the entire time. So in the stock test, it was, around 2.1 to 2.4 gigahertz while running the game. But in the optimized test where we undervolted the CPU, that gave us a little more TDP headroom that it could stay in the top turbo state the entire time at the 2.9 until it throttled. It actually throttled quicker even though it was undervolted, and the reason it did that was because it was running at a higher clock speed, which used more power, which eventually said, you know what, we're going to rein it back. But once again, it did it slow. It actually maintained it about 2 gigahertz for a long time, even though it was throttled, before eventually coming down to the full throttled state of about 1.4, 1.5 gigahertz. Once again, didn't affect our frame rate in the game we were playing. But, you know, is it worth it to optimize? You can undervolt, you'll be able to play your games at higher frame rates. And what I've noticed is if you go to a loading screen and the clocks drop down, it kind of refreshes the TDP signature that it's using and allows it to boost back up once it gets to the next scene or the next thing loads. So depending on the game, you may get a pretty good experience by doing that, especially if it's something that's actually CPU heavy. I haven't run into any games that are really being affected too much when it is throttling. It's just not an issue when the CPU isn't throttling the graphics. So that was the big question. Can you optimize so it doesn't throttle? You can. It's still going to eventually throttle. There's some things you can do to alleviate that. Potentially, that maybe we're going to have to do another video, but you could potentially turn off turbo and undervolt and keep your clock speeds from jumping up. That will keep the TDP down low. And also, I should note that most of these tests that we're running should be valid for the Surface Pro 4, and the reason I say that is all of the throttling we're seeing is based on Intel's limits that they have programmed into their chips, along with the manufacturer setting a few parameters. So it's not really a heat issue, it's, you know, a power limit issue. So as long as the Surface Pro 4 has been set to the same power limits, which I believe it's the exact same processor it should be, you should see the exact same results on the Surface Pro 4. You can leave me a comment and let me know if that is the case, but everything that I understand from this is everything I'm showing you here should be the exact same on the Surface Pro 4. Once I get my Surface Pro 4 i7 version, I will be able to do some more in-depth testing. However, that CPU is a little bit different. It's going to be pretty neat to see how well the Iris graphics stacks up against the NVIDIA GPU, which I'm pretty optimistic with doubling the execution units, with increases in the graphics that we've seen from Intel already on these Skylake processors, and also the 64 megabytes of EDRAM on the package. It might be a really incredible device. The other thing to keep in mind, on that particular chip, if you look at the specifications, the CTDP, the configurable TDP down of the normal Skylake, the i5, i7 that does not have the Iris graphics, is 7 watts. And the Iris version of it is actually a 9 watt down TDP. So it actually has more thermal headroom on that Iris 540 chip in the entire package. So that may give us the headroom we need to keep clocks up higher for longer and really have a kind of an incredible GPU device all in one in the Surface Pro form factor, which I'm excited to see. The last big question that we answered in this video was, does the NVIDIA GPU throttle the CPU when it's in use? And I may have worded that a little bit wrong, but the CPU in general is not going to throttle at all when using the NVIDIA GPU. I ran this thing Metal Gear Solid for hours and it did not ever throttle the CPU. So in the test I show in this video, I actually run Metal Gear Solid and then run Prime 95 in the background, and it still took probably 8 minutes after already having run Metal Gear Solid for 15 minutes for this to actually throttle. It's all about hitting the TDP limits that induces the throttle. However, even with Prime 95 running, even with Metal Gear Solid running, a CPU did not throttle until much later, and when it did, it only dropped by 100 megahertz. So the throttled it a smidgen, but that was it. So you really don't need to worry about your Surface Book throttling when you're using the NVIDIA GPU. It's just not going to throttle unless you're doing something absolutely insane and crazy. Maybe if you're rendering with the GPU, you might run into a situation like that, but even so, you're going to be at, instead of 2.9 gigahertz, you'll be at 2.8. I don't think you're going to miss that teeny little percentage point. So there you have it. More in-depth throttling information from the CBetters channel. Please click subscribe. We love to get the feedback, and if you have any more questions that we can help answer, I will do what I can for you. And thanks for watching, and we'll see you soon on some more videos.